Today we'll be solving more logarithmic equations, part 2. So now we're going to be looking at more complex logarithmic equations to solve. First thing we're going to have to do is apply some sort of log property. In this case, we're going to condense logarithms first. When we do so, we know plus sign means multiplication when we're speaking of logs. So log base 3 of x minus 5 times x plus 3 equals 2. And now we're ready to write this guy in exponential form. So that's our next step, write in exponential form. When we do so, 3 to the second power equals x minus 5 times x plus 3. Or 9 equals x squared minus 2x minus 15. Now, our next step is just to solve, which this is a quadratic equation because the degree of the equation is 2, meaning the largest exponent is a 2. So we have to make it equal to 0, so we'll subtract 9 on both sides. 0 will equal x squared minus 2x minus 24. Now, when we factor this, we're asking ourselves factors of 24 that when I add them together, I get negative 2. And in this case, we have negative 6 and positive 4. Right? They multiply to be negative 24, and when I subtract from them, I do get negative 2. So 0 equals x minus 6 times x plus 4. And what we'll do next is we'll set each factored piece equal to 0. So x minus 6 equals 0, or x equals 6, and x plus 4 equals 0, x equals negative 4. Now, our last step is to check for extraneous solutions. So remember, we cannot take a negative log. So we just have to ask ourselves, when I plug 6 into our original equation, not our condensed one, do we get a negative log anywhere in that equation? Right? We know 6 minus 5 is 1, and 6 plus 3 is 9. So in this case, x equals 6 is good. However, when we plug negative 4 in for this x, we have the log base 3 of negative 9, which I can't do. Or here, log base 3 of negative 1. So this one is extraneous. I want you to take a minute or two and try the example you tried. Hopefully for this example you try, you recognize when you condense the logarithms, you do get log base 2 of x minus 1 times x plus 1. And when you write it in exponential form, 2 to the third power equals x minus 1 times x plus 1, which equates to 8 equals x squared minus 1. Now you can either solve it by factoring or you can solve by square roots. Just remember, when you solve by square roots, you do need that plus or minus in your final answer. However, x equals negative 3 is not going to work because when I plug negative 3 into my original equation, notice I have a negative log, which doesn't make sense. So we only box x equals 3. Let's look at another type of problem. Again, our first step is going to try to condense. And remember, with subtraction with logarithms, that means we are going to divide. So natural log of x minus 4 over x plus 1 equals natural log of x plus 8. Now, because I have the same logs on either side of the equation, I could rewrite an exponential form, but the natural logs are just going to cancel out no matter what. So we're ready just to drop the natural logs and say x minus 4 over x plus 1 equals x plus 8. And now we just solve an algebraic equation. Remember, to get rid of the fraction bar, we're going to multiply both sides by x plus 1. So on the left side, we'll be left with x minus 4. And when we distribute on the right, we do get x squared plus 9x plus 8. This again is a quadratic equation, so we want to make our equation equal to 0. So I would subtract the x and add the 4. So we have 0 on one side of our equation. So 0 equals x squared plus 8x plus 12. Now we're ready to set up factoring. Now, we are going to do factors of 12. When I multiply them, I get 12. They add to give me 8. So we know 3 and 4 multiplies to give me 12, but adds to give me 7. So that's not going to work. We know we have 2 and 6. When we multiply those together, we get 12. When we add, we do get 8. And we want positive 8, so both factors are positive. Now we're ready to set each factored piece equal to 0. Okay, so x plus 2 equal to 0 and x plus 6 equal to 0. Or x equals negative 2, x equals negative 6. Now, when you plug negative 2 into the original, are you going to get a negative log? And the answer to that is yes, you will on the left-hand side. So that means x equals negative 2 is not a solution. What about x equals negative 6? If you plug it into anywhere in the equation, do you have a negative logarithm anywhere? And in this case, yes, you do. You have a negative log, so that is not a solution. So our final answer for this one is no solution. The end. Take a minute and try the next example you tried. Hopefully you find for this one x to be 1 over 5, which if you were to plug 1 over 5 into the original, equation, you don't get a negative log with the log on the left side, and you don't get a negative log on the right, so we're good to go. So you condense, remember the subtraction means divide, and because you have common log with the same base on either side of the equal sign, we just drop the logs and solve the algebraic equation. Okay, we have one more type of problem. And the first thing is, remember our common theme for these types of problems. We condense first, write in exponential form, solve for x. So in order for us to do this, I can't just drop the logs because we have this rando plus 1 on the right-hand side of the equation. But what we can do is we can subtract log base 6 of x plus 2 and isolate the number without a log. Okay, so when we do so, we'll have log base 6 of 8x plus 9 minus log base 6 of x plus 2 equals 1. Now this looks like a problem that we've solved recently today. Okay, remember that subtraction means divide when we're referring to logarithms. So log base 6 of 8x plus 9 over x plus 2 is equal to 1. So now that we've condensed, we can write in exponential form. 6 to the first power equals 8x plus 9 over x plus 2. Now, to isolate our x's, we have to get rid of the fraction bar. So we're going to multiply both sides of our equation by x plus 2. X plus 2's cancel out on the right, so we'll have 8x plus 9. And on the left side, make sure you distribute. When you distribute to both terms, you'll have 6x plus 12. Okay, now we're ready to solve. I would probably subtract 6x and subtract 9. Okay, so 3 is equal to 2x, or x equals 3 halves. Now, we do have to double check and make sure we don't have any extraneous solution. If we plug 3 halves into that first logarithm originally, do we get a negative log? No. What about for log base 6 of x plus 2? No. So guess what? We should be good to go. This one is good. Try this last example you tried. Hopefully for this one you do get x equals 9. When you plug in 9 into the original, notice you were not going to get a negative log. You'll get log of 27 minus 3, which is a positive number. And the same thing is true on the other side. For log base 2 of x minus 6, if you plug in 9, you get log base 2 of 3, which is not going to be negative. Hopefully you recognize to subtract the log base 2 of x minus 6 first, then condense, write in exponential form, then multiply both sides by x minus 6, solve an algebraic equation. You guys are officially ready to practice now. The end.